Today we hear about a new medical procedure which offers an innovative way to find out what's going on inside our intestine. This is a pill you swallow that has sensors to make measurements inside your gut and then transmit those measurements wirelessly to a gizmo outside the body.
You're listening to The Science Show on Cambridge 105.
In this section called Scientists at Work, we talk to people who, for some reason or another, find themselves working, researching or thinking about science in Cambridge, England. First up today, we hear about a new medical procedure which for the first time has become available in Cambridge at the private Spire Cambridge Lea Hospital in Impington. If you've ever suffered from a problem in your tummy, you'll know how distracting that is, to say the least. Finding out what's going on deep inside you is going to take a bit more than a blood test. In some situations, you might even have to eat something radioactive so that the doctor can see how fast this radioactive tracer moves through your guts. And since it takes days for today's meal to pass right through you, you might be signing up to a lot of trips back to the hospital, going into X-ray. So it's an awkward investigation.
But now I'm glad to say there's a tablet-sized device called the SmartPill. You swallow it and it takes measurements as it makes its journey through you.
It's being introduced to Cambridge by Dr. Stephen Middleton. He's a consultant at Addenbrooke's, a lecturer for Cambridge University, and he is working at Spire Cambridge Lea Hospital to offer this new investigation. I caught up with him last week to learn about this intriguing device. I asked Dr. Middleton what the device does for us.
Well, this device will study the movement of the intestine, right from the stomach, the small bowel and the large bowel. So what we're interested in is the speed in which products, food for instance, is transmitted through the intestinal tract. Okay. There are conditions which are caused by an abnormality of movement of food through the tract. So for instance, some people have a very slow gastric emptying, so their stomachs take a long time to empty, and that can cause bloating, pain, nausea, even vomiting in extreme cases. There's also conditions where the small intestine, which is a long, thin intestine, about 15 to 20 feet long, there are conditions where the movement through that is very slow as well, or very fast in fact, and we can identify that with this capsule. We can also look at the large bowel and see if it's very slow or very fast. So we can look at the whole intestinal tract in one go and see which bits are working well, which bits are not, and then hopefully that will explain why the patient have got their symptoms, and we can target treatments to the exact problem rather than just guessing from their symptoms. The problem is some of the symptoms can mislead doctors. So the patient will feel bloating. That could be, for instance, because of the stomach, the small bowel or the large bowel. They can all cause the sensation of bloating, but we don't know which one is wrong, is abnormal, and we can identify that and then use a specific treatment for that part of the body.
So I've come to you as a patient and I've got some issue somewhere, I'm feeling bloated. What would you have normally done in terms of investigating that sort of thing? So
the first thing you would do is obviously take a careful, what we call a history, by asking questions to try and see if there's any clue as to what the problem is. And sometimes you can home in on a particular area and a particular condition that the patient's got. Other times you can't. The next step would be to examine the patient to see if there's any clear abnormalities that will again give rise to a diagnosis at that point. But very often again there isn't anything that you can find. Then you do start your investigations. Mm-hmm. They usually begin with a set of blood tests and some simple clinical investigations like an X-ray, an ultrasound. Very often we need to look into the stomach, for instance, with an endoscope, or up into the large bowel using a colonoscope. So gastroscopy, colonoscopy, ultrasound, and sometimes CT scanning. So all those things are still necessary to exclude serious conditions like ulcers, cancers, for instance, things like colitis, Crohn's disease, celiac disease. We still need to look for those. But in the majority of cases, they're not present. So most patients don't have those conditions. Their symptoms in most cases are due to what we call a functional abnormality, whereby the bowel movement is wrong, either the stomach, small bowel or large bowel. The actual movement, the way the bowels are controlled and move, is causing a problem. Now, testing those is much more difficult, and up until now it's been quite an invasive test to look at function. So we've had to put catheters down with pressure transducers on, or use radioactive isotopes to monitor how quickly or slowly food is processed through, is passed through the gut, and that's radioactivity. So this pill will offer us the ability to measure the speed in which things are passed through the stomach, small bowel and large bowel without any radioactivity at all. All the patient has to do is swallow this pill. And then they carry a recording box around, a little box, about the size, just bigger than a mobile phone. And for 5 days or so until the capsule comes out, which the box will tell them when the SmartPill has been passed. And then all the data is collected on that device, and they just bring it back or post it back. And then we can analyse the data, and they haven't had to change their normal activities at all. If they had the current radionuclide, the radioactive test, it means going back to hospital every day.
So you would eat, drink something?
Yes.
And then the machine has a look for this little bit of tracer which is going through them?
Exactly.
And you come back every few hours or every day?
It can be every few hours initially, and then it'll be daily at least until the radioactive materials come out.
And the net discovery from that would be transit time?
Yeah, it gives you the transit time, again, of the stomach, small bowel and large bowel. But what it doesn't give you is all the pressure waves.
Oh.
So the capsule, in addition to giving you the transit time without any radiation and without the need to go back to hospital all the time, also gives you the pressure waves in the bowel. So you can see when the pressure is going abnormally high or maybe not working properly at all. So it gives additional information which could be extremely useful for helping to treat patients. The ability to pass wireless devices into the gut has been around for a long time.
Yeah.
I've been using them since the late 80s, but only in research. So we used to have devices that would measure pH, temperature, and would measure pressure, but not all together. So what they've done with this device is a company, the SmartPill Corporation, and initially developed it, and they're based in Buffalo, New York.
Yes.
They have just sold the product, but they sort of championed it through from the late 90s, through all the regulatory bodies like the FDA and the European Union, etc., and did all the basic research on it. But the product essentially combines the ability to measure pH, pressure, and temperature. So it's got 3 devices on it which will measure those modalities and then transmit it wirelessly to a receiver. So it's very convenient in that sense for the patient. There's no wires involved at all, no radioactivity, etc. It also has a little battery which can last for several weeks. The device is quite efficient. It doesn't have to draw a lot of energy from the battery. Unlike some devices, like the pill cam, which is a little pill that takes photographs.
Gosh,
because of the photograph
Yeah.
and the light, it's very demanding. It
Yeah.
only lasts for about 6-7 hours.
Mm-hmm.
But this will last for a lot longer than that.
Because it's just taking a few readings.
Exactly.
And is it Bluetoothing them to this little device, or it's got some proprietary Wi-Fi?
I think it's got some proprietary Wi-Fi, yeah.
Something like
Yes,
that.
yeah.
A lot of people will be wondering if you reclaim this device, or is it disposed of?
No, it's disposed. And the more that are done, the cheaper it'll get, obviously.
Yeah.
At the moment, it's about £500 for the actual capsule.
Yeah, that's still a big deal.
It's still quite expensive, but it's surprising how long it's taken the company to get it through. These products are extremely difficult to get onto the market, onto the medical scene, to go through all the clinical tests and all the research, because it's got to be proven without doubt that it's safe and that it will contribute and it is accurate in identifying these conditions. That's a very rigorous process.
It is bizarre. It's not as if it's a great piece of damaging stuff.
No,
no. There's plenty of sports gear out there which
absolutely
is doing very similar stuff, isn't there?
It's taken over 10 years of hard slog to get it through.
What sorts of things could you be looking forward to now?
Well, I think it's a natural evolution of the investigation of patients. So after we have tested patients for the common conditions that are really, really important to exclude, like cancers, then because most of these symptoms we know are due to functional abnormalities, if patients prove difficult to treat, obviously in some cases we would try simple treatments first perhaps to see if that's all they need. But when you get to a point where the patients aren't responding as you'd expect, which is pretty common for this sort of condition, then this capsule could be used essentially to see what actually is happening inside the gastrointestinal tract. And as it becomes cheaper and as we get more experience with it, it can be used more and more because it's minimally invasive. It's not a particularly invasive procedure. It's a bit like an ECG of the gut, if you like. It provides a lot of information that's extremely useful, and the more we use it, the more familiar we will be with the results and how to interpret them. I think we're going to find a lot more information is available from these recordings than initially meets the eye. Currently we're just looking at transit time, but the pressure studies, we have minutes, second to second pressure readings all the way through. And all that information eventually we'll be able to use, hopefully, and maybe extend the tests to challenge people with different foods, work out which tablets are better for them. It's got a lot of potential.
In the short term, you have now a much less upsetting way of measuring the time it takes for my food to go from one little bit of my gut to another bit of my gut. What you have now is something which is way, way less damaging,
yes,
less intrusive, less inconveniencing,
yes,
and more informative.
Exactly.
Many thanks to Dr. Stephen Middleton, talking there from Spire Cambridge Lea Hospital. What do you think, Chris?
Well, it sounds neat, and I was wondering, what does this pill look like?
It's like a very large pill. Actually, you can see electronics inside it, and they're all protected by a kind of yellow, rubbery, translucent coating.
Sounds a bit large and difficult to swallow. And expensive, too. It says here on my notes that the whole investigation costs around, is this right, 1,500 quid?
Well, yeah. But I thought, if somebody's suffering long-term with IBS, I really don't feel that we are qualified to judge the worth of it. I don't think we should ever poop on a good idea. That's pretty much all for today's show. Scientists at Work is made by the Science Show team on Community Radio Cambridge 105. You can also find past episodes on the website www.cambridge105.fm. You can also subscribe to future podcasts with the iTunes Store. You can get in touch with us on the email science@cambridge105.fm or on Twitter @105science. Till next time, it's bye from the Science Show team of Roger Frost and Chris Creese.
You're listening to The Science Show on Cambridge 105.